let's get started. So the next talk is Robert McClay from Tech. He's gonna talk about Xalt, a tool to figure out what your users are doing on your supercomputer.
Okay, thank you very much. I'm Robert McClay. I'm from the University of Texas. I have colleagues, Mark Fahey, who was at Nix, is now at Argonne, and other colleagues, Ruben, who's from Argonne, and my student, Sandra Sweat, who are working on this project. What is Xalt? Xalt is a tool, it's a National Science Foundation funded project with PIs, me and Mark. And the goal of Xalt is to take a census. We know from accounting how much a user spends, but have no idea what they use. And we'd like to have a better idea of controlling the system. How many people in this room are system administrators? How many people in this room aren't system administrators? What are you doing in this room? Anyway, so the problem as a system administrator is, especially at an academic place like we are, we get students, freshly minted graduate students who don't even know how to spell Linux, and asking where their folders are. And so our users range from complete newbies to experts who know more than I do. And the issue is that we need to help them. And so we want to know what they're doing. We want to get a better idea. We want to be able to track what they're using, because we're building stuff, and we'd like to know whether we should continue to build it, because if nobody's using it, we don't need to build it anymore. Let's do something else. And Xalt is currently running at TAC, the site I come from, at Nix, at University of Florida, at KAUST, also at NCSA, and it can integrate with other tools like TACstats, which I won't bore you with because I don't have time. So our goals are to be extremely lightweight. We want the users to not know anything that's going on. We'd like to provide provenance data, i.e. I'd like to be able to tell a user, if they asked, 6 months ago you ran your program, you ran this program with this environment variables, and this was the command line on this machine. We'd like to know what libraries people use. And we want to collect data into a database and for analysis, but you could also use tools like Splunk or Elasticsearch to do this analysis as well. So we got to do something. We got to get into your code. So what we do is we hijack the linker. That is, we have an LD script, LD shell script, which does what we need it to do and then calls the real LD. And what it does is it generates assembly code, it essentially watermarks your code, and then it also provides a trace map so we can collect how you linked your code, and we collect that in a JSON file. Then what we used to do is we also hijacked the launcher, MPI run, IB run, whatever your tool is, and it's a shell script which then would track the start of your job, at the end of the job, so we would know how long your job was, as well as what environment variables you had, and we collect that also in a JSON file and collect that. Well, fortunately, I don't have to do that anymore, and I'll explain why later, but it works, but it's problematic. So what we do is we have at least 3 methods that we support to collect the data. So we produce JSON information. We can write it to a file, which we can collect nightly. We can send that information directly to syslog, which means your tools like Splunk or Elasticsearch, Logstash can analyze it there, or you can write straight to the DB, and we have sites that use all 3 of these methods. So Carl, the previous speaker, was very nice to talk about LMOD. I happen to be the author of LMOD, and we do use the hierarchy. Well, you don't have to, but we use the hierarchy. And one of the things that's a problem with the hierarchy is module avail no longer tells you everything that you can load. So I have a command called module spider, which says you walk the tree and it can figure out modules that you can't load but are available by loading other things. You know, this version of Petsy is only available with this compiler and this MPI stack. Well, what's cool is a module tells you pass. Well, if you've got all that information, you can take what I call a reverse map, do the reverse, take directories into path, into module files, so you can say, hey, these are the modules that people use, not just the paths. And for anybody on an HP system that doesn't use modules, oh good, you're all set. Or at least not willing to admit to it, that you're crazy. So this is a very useful thing. So for example, I can map between this crazy path right here to a particular module. The other thing is that when I was doing this well, since I know the author of LMOD, I have this feature that in a module, I want to have this path, this Xalt path, be in front of everything else. So I've modified LMOD to support this thing called priority. So I have a priority path which says every time I rebuild the path, I make sure this one's in the location where there's priority of at least 100. So you can have a bidding war, but most of the time nobody else knows about it but me, and you don't tell anybody, that you can set priority paths. So when the module command reruns, it swaps that path all the way to the beginning. And just in case if you ever need it, you can set a negative number to make sure something's all the way at the end. Okay. I should have started my talk off like this. We have a few big data people still left? Okay, good. Big data sucks. I mean, it's a huge pain in the ass. Well, I guess I should say, if it was easy, anybody can do it. So, and one of the things I've learned, well, first of all, I started out knowing zero about databases, and now I know just enough to be completely dangerous. The things that I thought were easy turned out to be hard, and I thought 2.1 billion was a big number. It's not. So we produce about 8 million jobs a year on Stampede. It's a 6,400 node system with about 500,000 cores on it if you count the mic cores. And so we've got 8 million jobs. We keep track of the environment variables. The environment variables we get about 250. But you multiply those two numbers together, and all of a sudden you're at 2.1 billion. So my database used an integer as the index, a signed integer, which tanks out at 2.1 billion. So I can't store any more environment variables. I'm redesigning the database. But keeping track of the environment variables is huge. So I'm going to work a different way to do this. But anyway, and I was surprised that was the biggest thing we have. So a database change, so I'm changing the database to support environment variables. I want to be able to provide provenance data. I want to be able to tell you how your program was built. I want to be able to tell people you put a ticket in as a user, this job is bad, and I'd like to be able to say, give the people who are answering the ticket, here's the environment, here's the modules they had loaded, here's the things they used. But in terms of doing SQL analysis, I don't need to record all those variables. So I'm going to change it, so I'm going to store the environment as a complete blob, and then I'm going to filter it to cut down on the number from around 250 to around 20 or so. So I've been running Xalt for about a year, as you might have guessed, or a little over a year now, a year and a half. And one of the things that certainly are more common here, but in the US, we don't see a lot of people using UTF-8 characters. People putting tildes in their names. I mean, you get to America and those things in your names disappear. We don't know how to deal with them. But Unix supports UTF-8 directories, UTF-8 names, and first time I discovered somebody named a directory with a tilde in it, and it broke LMOD. I mean, not LMOD. It didn't break LMOD, it broke Xalt. And so I had to support UTF-8 characters. That took a while to sort out. And I've changed to use this query cursor execute style of putting in data, and this also prevents SQL injection, so I don't get in trouble if somebody names their program Johnny drop tables with a couple semicolons thrown in the right places. And it also supports UTF-8 characters. So, and this is something I think is a mistake on my part, which I'm going to try and resolve as time goes on, but I'm doing stuff in user space. I'm hijacking the linker, and I'm going to do something there, and right now I'm calling Python. And Python I'm running with in your environment. And most users, this is a very sane thing to do, but I want to be 100% safe. And so I've gone to using, there's 4 ways you get in trouble with Python: LD library path, Python home. I discovered there's yet another one that I didn't know about until I got here. But what I'm doing right now is I'm defining LD library path to be the one that you configured it with, passing no path in, using the absolute path to the Python you configured with, -e to say ignore these 2 variables, and then your Python script. So, and that means everything has to be hard-coded, and if you use a shared file system, this means that you have to have a unique install per cluster, even though you're on the same home file system. Because things like base name move around. Sometimes it's bin base name, sometimes it's user bin base name. Anyway, so that's what I'm doing to protect me as well as I can right now, but I think I'm going to have to move away from Python for the stuff that's in user space, something that's got to be statically linked or isn't affected by, pip install and stuff. So you're going to collect this data. You better find something to do with it, or we're just filling up disks with useless data. So how can we use this data? Well, one of the ways we've been able to use this data is to deal with users abusing certain queues. So we have a large mem queue with nodes that have 1 terabyte. And it's like there's 16 nodes in that thing, right?
Yes.
Thank you. And it's and it was getting abused. It was getting it was getting heavily used by a large chemistry code, and we were able to use Xalt to find out what codes were being run, and we were able to use a tool we also have called TaxStats to check memory usage, and showed that these people couldn't run in the normal way, the way you do handle normal nodes, namely, 16 cores, each getting about 2 gigs apiece. They couldn't run their jobs, but if they could run in reduced weightiness, i.e. use half the cores, or a quarter of the cores, and get more memory per, they could run the normal queue. So we were able to move those users out of the large mem queue back to the normal queue, and the wait time went from 4 days to 2. And the definition of a crisis, in my mind, is at a center is the center administrator, the center director is looking at the queues on his phone while he's flying from place to place, checking them, seeing if we're doing well or not. So the center director's interest is a crisis. So we've also, at our site at least, when you create an account, you have to also say that what your field of science is, and it's selfish. We don't check to see if you say you're an engineer and you're really a chemist. We don't know that, but we can take that data and look at how you run on our system and look at what community codes, and we can provide anonymized, take the username, the charge accounts, and we've got a unique mapping and add a field of science. So we've done some preliminary analysis which tells you the things you already know, which is that, yes, chemists use VASP and NAND and all that stuff, and there's a lot of Python stuff going on. But it's nice to be able to prove that that stuff's there, and we'll be able to do more with it as time goes on. So, as I said, we used to only track MPI jobs, and while for a site like TAC, that's pretty good. We get many of the jobs, most of all of the big SU jobs. In other words, take up most of the charge time, but not the number of runs and not the number of things in terms of helping users. In fact, it tends to be the smaller the jobs, the more help they need. So we want to be able to track non-MPI jobs. And so hijacking MPI run or the equivalent at each other site was a maintenance nightmare. And so we're using an ELF binary trick to track jobs. So turns out that ELF has these has this thing, a NIT array and a Fini array, which, yeah, I know. Oh, yeah. Okay, anyway, so you can track, you can register a function into those things, and this function will be called before main, and this one will be called after main. And, okay. All right. None of this stuff matters. So, if you're going to do this, you're going to collect a lot of data. So, depending on your site, you may or may not want to copy CP or things like that. But I was talking to some colleagues in a bio site, and they said their #1 job was awk. So there may be things you want to track that I didn't think of before, but you can choose how you want to select the things you want to check or not. Okay. Now we have to see whether the demo gods are going to be demo. Oh, Christ. Let's try it again. Okay. Should have thought about the fact that I have to restart it. Okay. Some days. Right. Hopefully that's readable. I'll have to move over something.
Right.
Okay. So, I'm running a module system. Don't you run a module system on your laptop?
Who doesn't?
With the Xalt, and so I can do type -A on LD, and it shows that I got the one in Xalt rather than the one in the system. If I build something, it built it, and I'm writing stuff to this directory, and so it built, I was testing this thing, and so it just built one right now. And so I'm going to move that, and we'll do that again. So there, I got it. That was generated immediately, and it has information about the jobs, it has the link line and all stuff like that. And so I can run it. This is just a simple hello world code. It just does that. And I've got run information. So I didn't need to do anything, it magically appeared, and one of the things that you're going to have to filter these things, and so you can track what's performing. You can put a debug library and set LD library path, and you can find all kinds of information, and it tells you, for example, it can tell you that, yes, I'm tracking, it has the right state, it has the right rank, and the host name was accepted, and the path was accepted. So you can do things like you can control what things you want to track, what things you don't want to track, and all drive it to a database and analyze it. I'm done.
All right. Thank you, Robert. We have time for questions.
How do you treat data privacy? I would guess everybody would say this may be opt-in, but never ever you should take down what somebody's typing and just without asking that every keystroke he's doing is written to some database.
Well, we're not tracked. Well, I'm only at our site, we're only tracking things that run on the computer. So you typically, it's what the job runs. So we're not tracking what you type on, although we can. We're not doing that. And this is actually an interesting problem. We have this thing called HIPAA, which is medical data, and so we're gonna have to figure out that we don't trace when if you're doing stuff in HIPAA, this stuff doesn't get traced. But yeah.
And quick one more, have precompiled binaries where you can't print anything?
Well, but I'm using I'm setting LD preload, so I will track it. Because LD preload will hook into those functions even though it's precompiled. So I can even track things like DDT or something that comes from commercial. I'll know that it ran. Yeah.
What does this have also for ODT? I mean, ODT is the same thing, right?
Well, I get to control what gets it may be the same. I'm not really all that strongly familiar with LD, but I'm also capturing the environment, and I get to control what I capture.